Let's move up the food chain to look at a few things that are carbon intensive at 100 grams to 1 kilogram. Start with a mug of tea or coffee. Looking at the carbon footprints, 23 grams of CO2 equivalent for black tea or coffee. Boiling only what you need. So again, remembering boiling water. If you measure by mug and only boil that much, and not to full boil, but just something like 85 degrees centigrade, you're going to save carbon. 55 grams of CO2 equivalent when you add milk. Again, boiling only what you need. So milk adds quite a bit, more than twice here. 74 grams CO2 equivalent is the average with milk. Boiling double the water you need, which is what mostly happens on average around homes, offices, public places, restaurants, etc. 236 grams CO2 equivalent for a large cappuccino with all the machine and the steaming and the hot superheated water and so on and so forth, and it jumps to 343 grams of CO2 equivalent when you take a large latte with all that milk. Why does milk add so much? Look at the CO2 equivalent in kilograms for a latte. Most of it is tea or coffee is only a tiny bit. Most of it is just milk. Same thing with cappuccino. So you have tea and coffee and then heating it up, adding here. So this is not negative, it's just got shifted somehow. Heating up adds a little bit. White tea or coffee boiling twice as much water adds a lot of heating cost. White tea or coffee boiling just what you need reduces that cost quite nicely. Black tea or coffee boiling just what you need brings you down to be quite environmentally friendly. So it's not just that you enjoy your coffee and tea and maybe you want a little milk in it, you can be blamed for it, but you're aware that milk is a massive operation in terms of environmental footprint. Which milk should I choose? Environmental impact of one glass or 200 milliliters of different milks turns out this way. Looking at emissions associated with the production, land use in square meters, and water use. Right? You feed the cows, you graze the cows, you give them water, and they produce milk. Dairy milk, quite expensive in terms of emissions in kilograms. Rice milk is cheaper, also uses less land and less water, even though rice paddies are blamed for emitting methane. You know that dairy has methane emissions as well. Soy milk is cheaper than rice milk. Oat milk is cheaper than soy milk in both emissions as well as land use and water use. Almond milk is even cheaper than that, but almond is a water intensive crop, so it needs more water than, let's say, rice milk here. Overall emission is lower, and of course growing almonds in a place like California is going to make things much worse in a place where water is already scarce. The production methodologies and other things create dairy milk's climate impact to change by location. So we are looking here at greenhouse gas emissions in kilograms of CO2 equivalent per 200 milliliters of milk. So Latin America and Caribbean somehow have a large footprint for dairy milk's production. Africa is lower. Global average is over here at 0.6 kilogram of CO2 equivalent per glass. Asia is lower. North America has become quite efficient. Europe is even more efficient, and Oceania, which includes Australia and the island countries, is the lowest. So coffee, tea, complicated story on how you take it, how much water you boil, how much milk you add, whether you make a latte or a cappuccino, and so on. And the human behavior is strange that interest in vegan milk is spiking, but there is a jump every January, as if there is a epiphany and New Year resolution or so. So the UK search interest in milk alternatives, this is from Google Trends, over 2012 to 2018 shows a nice upward trend for soy milk and almond milk, but somehow the spike occurs at the beginning of the year. It drops off, it jumps up again and goes down, but overall, fortunately, there is an upward trend. Oat milk is picking up more recently, and rice milk hasn't made much of a trend in terms of usage in the UK. Okay, next up on the list is a mile by bus. We all know that public transportation is very good, reduces pollution, reduces emission, reduces parking space needed, reduces congestion, and so on and so forth. You get 15 grams of CO2 equivalent for one of the 20 passengers squeezed into a minibus in the suburbs of La Paz, which is very efficient, but how safe is it? Well, especially with the pandemic, you know that people just got very weary about getting into crowded places. 150 grams of CO2 equivalent is typical of a city bus passenger. So the bus has to go, and if it is full, obviously its average emission per person is going to be lower, but if it is going empty, then it's going to have a bigger emission because it's burning fossil fuel anyways. So it's not just La Paz, this is from India. You can find similar figures for other poor countries where a bus is loaded everywhere with people. Obviously not very safe, but it is done routinely, and the idea is good in terms of reducing carbon footprint, right? That's not what they are thinking, of course. They are poor and they need to get to school. These are school children, and there are older people who are going to work and so on. So this is life in La Paz or in poor countries. So public transportation is obviously very good in terms of reducing the number of cars, pollution, public spaces, green spaces in cities, and so on, but safety is important as well. And now India is going more and more for electric buses, electric vehicles, which is not obviously going to reduce emissions unless the electricity itself is also coming from clean sources, because if you still keep burning coal for producing electricity, then you may be better off using LPG or natural gas engines rather than electric vehicles, which are being powered by coal burning power plants. So obviously, again, life cycle analysis and where the energy comes from and so on do matter. But there are other issues. People who ride the buses are not necessarily doing it for global warming reasons, as we said. It is more about poverty. So rich people, even though they can take the bus, often take cars as a status symbol. Often they are not full. There are only one or two people traveling. And they do that even if there is heavy traffic congestion in big cities like Bangalore, which is one of the worst, Mumbai, Delhi, Kolkata, and now Pune is becoming quite bad as well. So all these social factors and human behavioral aspects have to be accounted for as well. But in many places in the US, the poor people cannot even get to work with just public transportation, so they are forced to buy cars, and the cars can be old and very high emission vehicles. They cannot afford the efficient new cars. Just changing a car by replacing an old car by a new car, fuel efficiency and all the other related emissions like braking and so on can be reduced. But obviously, unless you are rich enough to buy a new car, you're not going to be able to afford it. So transportation as a whole is a big part of the emission, including the trucks that transport materials and so on. So public transportation is one part of the solution, but here we are just talking about per mile, what is the carbon footprint when you take a bus. Okay, riding a bicycle is better, as we said, but again, it depends on where you get your calories from. So we just keep getting into these loops about trying to understand carbon footprints of everything. Has to be understood end to end.